Jahan to all. Today I will discuss the second lecture of the unit number 3, context-free grammar. So the content to be covered today lecture is derivation tree. After that we will discuss about the leftmost derivation and rightmost derivation, and at last I will summarize it by the ambiguous grammar. Basically, whenever we will think about derivation, so derivation is a process of the replacement of a non-terminal in a string of terminal and non-terminal by the right hand side of a production corresponding to that particular non-terminal that you want to replace in order to generate the string that is of a terminal. So we want to replace the string of a terminal, we want to generate a string of terminals. So in nutshell, you can say if a string is let's A tends to, a production is A tends to gamma. If a string of terminal and non-terminal is alpha A beta, then you will replace this non-terminal by the help of this right hand side of a production in the particular derivation, in the particular string. Then it is called the derivation. So you can write alpha, gamma, beta in this manner. So this A get replaced by the right hand side of this particular production, right? So this particular process, the replacement of a non-terminal by the help of a right hand side of a production in a string of terminal and non-terminal is called derivation. So derivation, whenever you will replace only one terminal, then it is called the single step derivation, right? And denoted by the particular symbols. If you will perform the derivation in this form, A derives alpha 1, it derives alpha 2, it derives alpha 3, alpha 4, and dot 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 so on. You can say it derives alpha n, right? And after that it derives a string of terminal beta. So to shorthand notations, if you will skip so many steps and write down A derives beta in 0 or more steps, means derivation steps will be required here 0 or more. So you will append the star over here, right? So here we will take an example how derivation is performed. Consider a particular grammar S tends to AS oblique epsilon, right? And we want to derive a string A ki power 4. So how can we derive? We can start from a very starting symbol. In order to generate a string of a grammar, we will start from a starting symbol of the grammar, right? So S derives, so the productions corresponding to S will be AS and S tends to epsilon, right? So we will consider, we will enhance. If we will consider, we will replace this S by the epsilon, then we will get epsilon. So this is not a required string. So we will further extend this string. So we will use this particular production. So you will replace this S by AS. Once again, S is a non-terminal. So you will replace it by the AS, right? This S get replaced by this AS. Once again, you can replace this S, that is a non-terminal, inside the sentence CL form, AS, and after that you will write down, suppose in this manner, A and AS, right? And at last you will replace this S because the required string gets generated here. So you will replace this S non-terminal by the epsilon. So you will get A and epsilon. So in short, you can write down 4 times A ki power 4, right? So here you can see, basically this is a derivation steps, right? So you can either clearly mention each steps, or you can write down S generates A ki power 4 in 0 and more steps, right? Here, this is the string of terminal is called the sentence also. So the yield point that will be generated, or you can say a string of terminal that is generated by the particular derivation is called the sentence, and the strings in between that will comprises of terminal and non-terminals is called the sentential form. So basically, I will tell you here what is the language that is generated by the grammars. So language is a collection of terminal strings. So all the strings that will be generated or that will be derived by the particular grammar that by using the productions of particular grammar is called language. So the string of terminals that will be produced by the grammar and start with the starting symbols. So the derivation will start from the starting symbol. Then you can say the collection of those terminal string is a language generated by a particular grammar. For example, consider the following grammar. G is equals to S, A, and the production is S tends to SS and starting symbol will be S. Means you will compare it is equals to G is equals to B, sigma, and P, S. Some authors have written here T in place of sigma. So this is a set of variables. So only single variables or non-terminals are inside the grammar. B is the set of terminal, sigma is a set of terminals, or you can say T is a set of terminals. Here only one terminals A. This P is a set of productions. So here S tends to SS is a production rule, and this S corresponding to the starting symbol, which is non-terminal by nature, right? So you can see from here what is the grammar, this particular language generated by this grammar. So this grammar will generate S tends to, if you will start from the starting symbol, so this S get replaced by this particular SS. So you will place this SS. Now there is a two non-terminals inside this string. So you can take any one in the derivation and replace it by the next production. So if I will take it this one, then it get replaced by SSS, right? This S is replaced by SS and this S will be appended here, right? After that, once again, you can take the another one, this S, and replace it by, so it is S, 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 and S. This particular S is replaced by 2 times S, right? Because there is only single production. So you can see every time S get increased, but there is a no terminals, or you can say there is a no delimiters to delimit this string. So you will never get a string of terminals by this grammar. So language generated by this particular grammar is will be the phi. So language generated by the grammar can be written as language generated by the grammar G inside the bracket. So it will be the phi, nothing. No terminal string gets generated by this particular grammar. Next, I will take the second example here. Suppose grammar is the G times G is equals to S, comma C is a set of variables. This is a set of terminals. This is a production rule set, and this is a starting symbol. So grammar will start from S, right? And the production rule will be given here. S tends to ACA, C tends to ACA oblique B, right? So what happens? You can see, firstly, you will start from the starting symbol, right? And put it down the value or replace the S by the right hand side of the production. So there is a unique production here. Meaning is that there is only single production is here. So you will replace S by the ACA, right? This S get replaced by the ACA. Now, what is the non-terminal here? C is a non-terminal here. So what you have to do? You have to replace it C. So there is two choices here, ACA and B. ACA will further extend the strings or the sentential form, and B will terminate this particular string. If you will replace this C by B, then the string of terminals get achieved and no further derivation will be possible here. So you will replace it by the B, suppose. Then you will get a string ABA. After that, there is no non-terminal. So the minimum string inside this particular grammar is ABA, right? After that, suppose we will place it C by ACA, means this production we will use one times. So A, C, A will be achieved. After that, this C get replaced by B. So what you have, you will achieve A, B, A. If we will replace this C by ACA next, another further enhanced, suppose I have written AA, C, A, and we will again place this C by ACA. So the value will be A, C, A, and to terminate it, we will replace this C by the B. So we will get A, B, A, right? So you can see, if you will repeat this procedure n times, so what happens? If you will repeat this procedure n times, so you will get S derives in 0 or more steps A ki power n, C, B ki power n. If you will take the value of C n minus 1 times, then you will get A ki power n, C, B ki power n. After that, you will replace this C by B, so you will get A ki power A's power n, after that B, and right, and after, sorry, this is not a B, this is A ki power n, C, A's power n. So you will get A power n, B, A power n. So you can summarize from here the strings types. You can see A, B, A. You can see from here A, B, A. Meaning is that A square, B, A square. If you repeat this 3 times, you will get A, Q, B, A, Q. If you will repeat it n minus 1 times, then you will get A power n, B, A power n. So ultimately, you can see it will comprises the strings of type A power n, B, A power n, right? Where minimum string, the major role is played by here, because it is the set property methods. So to define the minimum string inside this set will be A, B, A. So what is the value of n? If you want to achieve A, B, A, then the value of n will be must be 1. So you can write down n is greater than equals to 1, right? So this is a set of strings, and the language generated by the grammar is this one, right? Either you can write down in this manner, set property method, or otherwise, if you want, you can write down in this manner. A is equals to A, B, A. After that, A square, B, A square. After that, A Q, B, A Q. And after that, you can write down A power n, B, A power n, and so on. So the minimum string will be constant here. Property is here, right? Now, you can see for this one, the grammar is given here, will be S is the set of variables, 0, 1 is the set of terminals, some authors use T, P is the production set that is given here, and S is the starting symbol, right? S is the starting symbol. So what type of language it will generate? You can see from here once again. You will start from the starting symbol. So the value is S tends to S drives. What is the derivation? Either it S drives epsilon. If S, I will replace S by epsilon, then the string we will achieve is epsilon, right? If S is derived, means S is derived 0 S 1, right? After that, this S get replaced by epsilon in the second step, because S is a non-terminal. So replacement of a non-terminal in the derivation will be possible. So if this S get eliminated by the or replaced by the epsilon, then you will get 0 and 1, right? What happens once again, if we will again modify it, again expand it, so it is 0. Once again, S is replaced by 0 S1. So it is 0 S1 and previous one will be here. After that, this S will be replaced by the epsilon, then you will get 0, 0, 1, 1, right? Now, suppose you will repeat this procedure 0, n minus 1 times. So what happens? You will get, if 0 power n right? S n minus 1, right? Once again, you will apply the 0, s is replaced by the 0 s1, so you will get 0. If nth step will be carried out, then you will get 0 power n s 1 power n. After that, s get replaced by the epsilon, then you will get the string of terminals. So 0 power n and 1 power n. So ultimately, you can see from here, first string is epsilon, second string is 0 1, third string is 0 0 1 1, fourth string is 0 0 0 1 1 1, right? After that, it is continuous. After that, 0 0 0 0 1 1 1 1. If this process will continue, you will get at last 0 0 0 0 n times, so 0 power n and 1 power n. If you want to write down it in a set property method, so how can you write down? You can write down in this manner: 0 power n, 1 power n, where what is the value of n? So the minimum string will used to tell you what is the minimum string. So it is epsilon. So how can you achieve the epsilon from here? By putting down the value of n is equals to 0, right? So n is always here is greater than equals to 0, right? So this is the language generated by the particular grammar, right? You can see. So you can I can summarize this particular method. You can try to find out the string of terminals from the starting symbol of the grammar, and collection of all those strings is called the language generated by particular grammar. Let's here I have modified this one by the 0 1, right? Epsilon is replaced by the 0 1. Then what is the grammar generated by the particular language generated by the particular grammar? So you can see here the minimum string is 0 1 now, right? It s derives 0 1. Instead of epsilon, the minimum string generated here is 0 1. So this definition is slightly modified. It will becomes n is greater than equals to 1, right? Or you can say n is greater than 0, not equals to, right? Now we will move towards the leftmost derivation and rightmost derivation. Basically, there is a two types of derivation possible in the context-free grammar case. First one is the leftmost derivation and another one is the rightmost derivation. In case of leftmost derivation, in order to derive a string of terminals, we will replace extremely left symbol every time in the derivation process. Then the process is called leftmost derivation. In other words, we can say the leftmost non-terminal in a working string is the first non-terminal that we encountered when we scan the string from left to right. For example, you can see this is a sentential form or intermediate string in order to derive certain strings of terminals. So you will scan it from the left, and the extremely left symbol, if you will replace this extremely left symbol by the corresponding production, so right hand side, by the production whose left hand side is x and right hand side is something. So you will replace the this x by the right hand side to the production corresponding to x. Then you can say this is a leftmost derivation. So extremely extremely leftmost symbol get replaced, right? Same is a rightmost derivation. Similarly, basically, in case of rightmost derivation, what we have to do? We have to replace the extremely right symbol, right? Or in order to generate a string of terminals, in each derivation or in each derivation steps, you can replace the extremely right symbols. Extremely right means you can scan the string from right to left, and the first non-terminal encountered in the derivation process get replaced. So non-terminal here encountered at the extremely right is by. So you will replace this by the right hand side of the production corresponding to by. If there is a production by tends to alpha, then you can replace by alpha, here, then it is called the rightmost derivation, right? So let us take an example. For example, this is a grammar given here. S tends to B A X A S oblique A B, and second grammar production is X tends to X A B oblique A A. Here we have to find out the leftmost derivation and rightmost derivation for the string W. W is given here B 4 times A B A B A A B, right? So in order to generate the particular string, I will start from the starting symbol, right? So from the starting symbol, I will choose the first production, because you can see we want to generate B. So how can you generate B out of these two production? Either you can choose this one or you can choose this one. So the first one gives you the B at the beginning. So you will select the production B A X A S, right? Now you can see the leftmost derivation is there here. So extremely left symbol. So scan the string from the left to right. So you will scan this string, and the first non-terminal encountered. So the X is the first non-terminal that will be encountered. So this get replaced now in the leftmost derivation. So what value? You will replace it by particular symbol, particular production X tends to X A B. So what you will get? B A X A B, right? After that A S. Now what? Once again you can scan from the left to right. So what will be the value? You can see this X is encountered first. The non-terminal X is encountered first. So you will once again replace it by the X tends to X A B, right? You will use this production and replace it from the right hand side products of this particular production X A B. So the value will be, you can see this is not correct. B A, this X will be replaced by X A B. After that A B A and S, right? Once again you can see, so this X is encountered. So you can see this X get replaced. What from which value it get replaced? So you can also memorize the strings here. I will get B A, right? B A, and we will require A A next. So you will replace this X by A A. So I will replace it by A A. A B A B A S, right? Now you can see the next symbol, non-terminal symbol from left to right is S. So this S get replaced by which value? This get replaced by, at last what you will require? You will require AB. You will require AB, right? Till now, till here, you will generate the string. Only AB is left. So this S get replaced by the particular production, this one, right hand side of this particular. So you will get the string B A A A A B A B A and A B, right? So scanning from left to right and finding out the possibility of non-terminal at the first position. So if you will get the non-terminal at the first position, you will replace it by the help of the right hand side of the production corresponding to that non-terminal. So this is a mechanism for the leftmost derivation. The reverse is for the rightmost derivation, right? In rightmost derivation, what you have to do? You have to find out the non-terminal that is extremely right. So you will start scanning from right to left, and the first non-terminal that will be encountered during this process get replaced by the help of a production, right hand side of the production, right? So बस 5 मिनट ले लूंगा, है ना? So you can see from here once again, I will start want to generate a string B A A A 4 times. After that B A B A A B. So first production will be used, will be same. S tends to B A X A S, and after that you will scan from right to left, right? So this S is encountered, this S get encountered, this is first non-terminal, so you have to replace it first. So what value I will replace it? You can see you will require AB. So S tends to AB will be a production, so you will replace it by AB. So you will drive B A X A AB, right? Once again, you can find out, you can scan this string, so you will get this X, right? You will get this X as a non-terminal when at a first position when you will encounter it, right? You will scan it from left to right to left. So you will replace it by the corresponding production B A. What will be required here? A will be required here. So what is the possibility here? So the possibility is you will replace it by the XAB. So I will replace it XAB AAB, right? Once again, you can see from right to left, this non-terminal encountered at the first. So you have to replace it. So what you will get? You will get BA. After that XAB, you will replace this X by the production corresponding to that X tends to XAB. XAB, after that AB, AAB, right? Once again, you can scan from here to right to left, you will get this particular symbol, right? And you will eliminate it by the, or you will replace it by the X tends to AA. So you will get BA, AA, AB, AB, AAB. This is a string of terminals because after that there is no non-terminal here. So string of terminals, whenever you will get the string of terminals, the derivation can be stopped. This particular string get generated. So at last I can conclude it. In leftmost derivation, you have to replace the extremely left non-terminal. In case of rightmost derivation, you have to replace extremely right non-terminal from the derivations, right? Thank you. So I think it is sufficient for today lecture. Thank you.